So welcome to the Chaos Mesh April community meeting. And this is Mila, your hostess of the evening. And thank you all for joining us today. We have a lot to cover and I see a lot of new faces. Is there anyone who would like to introduce themselves? You can go ahead right now because we have a lot of new ones. Maybe you want to introduce yourself, Sergio, or I see a new camera.
Okay. Yeah, well, I am Sergio. I am from Guatemala. Today we are going to talk a little bit of Chaos Mesh. So we are the guests today. And it's really a pleasure to be here to talk and to contribute a little bit with Chaos Mesh talking. Yeah, thank you for all.
Yay, thank you. And anyone else who would like to introduce themselves? All right, let's move along. So the agenda today, we've got a lot to cover. We'll start with the community sharing by Sergio and Jossie, and then we'll have a quick technical update from Chengwen, and then I'll give you all the community update, followed by a quick Q&A session. So let's get right into it. Let's welcome Sergio and Jossie.
Thanks. Just let me share my screen to show the presentation.
Go ahead.
There it is. I don't know if it's showing.
Yeah, it is showing.
Thanks. Well, first, it's an honor for us to be here today, sharing a little of the experience we're having with Chaos Mesh in San Carlos University. Now we're going to talk to you a little bit about chaos engineering in the university. A little about me. I'm a science and systems engineering student at San Carlos University of Guatemala. I currently work at IDT. I'm a freelance developer and a cloud native enthusiast.
Well, hi, I'm Sergio Méndez. I am an operating system professor at San Carlos University of Guatemala. I really like to play with cloud native technologies, in special the technologies of the projects of CNCF. I do some DevOps at Yalo, and I also have a community group here at Guatemala about cloud native technologies and that things. And I am also a Linkerd hero of February of this year. Yeah, let's just introduce a little bit because just to share a little bit about culture. Well, this is our faculty in Guatemala. This is the place where we study and we teach and everything. And this is the place where we are working on the thesis about chaos engineering. So yeah, it's a little bit about us and the university. So chaos engineering in the university. So what this thing is important? Well, in some way, it's a way to contribute into the CNCF projects and a way to get involved with the students in the CNCF ecosystem about cloud native technologies. So it's very, very important to be inclusive in that way. And another goal is to share with communities and this thing and explore new technologies, especially in the university, get involved with the university and doing some research about cloud native technologies. So right now we are trying to do some research about chaos engineering with the thesis of Jossie. It's like a really, really small story. Jossie was looking for that topic about what he can investigate or do some research for his thesis. And I proposed him, hey, why not to try chaos engineering? And I remembered because I am really involved in Linkerd and service meshes and that thing. Chaos Mesh has a very curious name. That mesh, like service mesh, sounds really, really awesome. And I say, well, this looks really nice. I am interested in this topic. And I found that Chaos Mesh is really, really easy, or at least in that moment, it seems like an easy option to test chaos engineering. And I propose to Jossie, why not to try to investigate and do some research about chaos engineering? And well, we mix this kind of things with the service meshes with Linkerd for faulty traffic and chaos mesh for chaos engineering and mix and doing some experiments to get some results and doing some research. And well, that's the thing that we are working right now.
I'm going to give a little bit of background for those in my country or that are looking for the first time in the community. What is chaos engineering? Well, in an easy way to say it is to cause failure on purpose to identify where and under what conditions our system can fail and improve our system, of course, because in some point is going to fail.
Well, let's get started with a little fun picture here. Well, we don't know if we are prepared about the chaos engineering. So this is an egg and well, is this hammer and trying to destroy these eggs. So we don't know if we are prepared to the chaos in the system. So let's get started with this. We have to choose the right pieces to get a stable system. So here are an example of some rocks. We're trying to find the balance to get the things working and to get a stable system in general. So in chaos engineering, it's really important to do this, to get a stable system, to run experiments about chaos and see what happens and get results and conclusions about the experiments.
Now, some of the thesis goals that I defined at first. First, learn about cloud native technologies, find quality source of information about chaos engineering, understand and implement chaos experiment. It's the main core of everything. And share this knowledge in my country, thing that I'm accomplishing right now. I think many classmates are looking at this right now. The current state of the thesis, well, all the historical background is already defined. With this, I mean the history that bring chaos engineering to us, because it's not an old science, it's relatively new. The transition from monolithic architectures to service mesh and the importance of applying chaos engineering. A definition of a guided steps to implement chaos experiments, and some of the experiments that I have already tried with chaos mesh. Some for the thesis and some for only for pleasure, honestly. The pod failure, the pod kill that we're going to see in some minutes, the usage of the CPU, network loss, and the network delay.
So let's move to some theory first. Well, talking about service meshes, it's really, really interesting. The thing that we use it is like they move in the layer 5, they can route some traffic and these things. The service meshes works in the same way as a proxy instance. So this proxy receives the traffic and calls to the control plane to decide what to do with this traffic. And finally, you can do a lot of things intercepting this traffic, like routing, generate faulty traffic, and that things. Let's move to Linkerd. Well, Linkerd is a service mesh, and as the same as chaos mesh, this use this pattern of sidecar containers. This sidecar contains the proxy that receives the traffic. But in general, the service meshes on Linkerd provides you this way to get some observability in your system, reliability, security using TLS certificates or securing your network traffic. You can take the advantage to generate a faulty traffic when you are using a Linkerd or a service mesh. And you can get this a lot of graphics showing the golden metrics, the latency, success rate, and the failure and that things. And for, of course, you can use the ability of the service meshes in some cases to implement the traffic splitting. This traffic splitting, you can, let's say, balance the traffic across different services, or you can route this traffic to a faulty container just to generate faulty traffic. That's the interesting part of just Linkerd here, to implement a simple way of chaos engineering using service meshes. So why we choose Linkerd? The next one. No, sorry. Back, please. Yeah, well, we choose Linkerd because it's really easy to use, really lightweight, and these things. It's really easy to understand how the service mesh work, in special using Linkerd, because it's easy to install, really lightweight, and really complements the thing, and has the features that we are looking just to test really basic stuff about chaos engineering. So that's the main decision. Maybe the easy way to use, install, and implement the things and the power of service meshes in this thesis.
Okay, now Chaos Mesh. Well, as you already know, Chaos Mesh is a chaos engineering platform that orchestrates chaos on Kubernetes environments by fault injection methods. We can provoke faults in pods, network, file system, kernel, among others. Now, why we choose Chaos Mesh for the thesis and for the experiments we're developing? Well, first, it's an open source tool. Comparing with other tools, it has more experiments to implement. We can customize some aspects of these experiments, like time between fails, the duration of these failures. We can check the status of the experiments in the dashboard that we're going to see further. Now, why we decide to combine Linkerd and Chaos Mesh? Well, first, it's very easy to use, both of them. They are easy to understand, easy to implement. They are a lightweight solution. And we think they complement each other for chaos experiments, as we're going to see. And both have a very nice dashboard visualization of the experiments. And some of the benefits that we find in the trouble during the investigation, well, with Chaos Mesh, we are able to identify vulnerabilities and potential failures in our architectures. We can improve our systems, create a proactive design, and have a better understanding of architecture capabilities. even if we are trying some experiments just for fun, we can see how far our architecture can go under certain conditions.
So let's move to the demonstration part.
Let's move for the demonstration.
Yeah, well, right now, this is the demo architecture and description in general, that the thing that we are going to show. This is like a part of the experiments that we are already doing in the thesis. Well, basically we have a cluster of Kubernetes on Google Cloud GKE. Basically we have two services. One is the client, the another one is an Apache service. Both are deployed as deployments on Kubernetes. So this client has this command CX to generate traffic and is calling Apache. So Linkerd here gets the traffic to the Apache and routes the traffic to a faulty container or faulty deployment. Let's call it the error injector. And we are going to split the traffic. Well, right now we are going to split the traffic like 90% and 10% in order to get some more cool graphics in this way. So the first part is to generate default traffic using Linkerd and get some kind of simple chaos engineering using the traffic and a service mesh. In the second part, we are going to use chaos mesh to destroy the Apache service. We are going to use the pod kill experiment and the pod failure. And we are going to show how Linkerd with the dashboard can show what is happening with the network and show what is happening with the golden metrics, the success rate, the request per second, and the latency, this main basic metrics for networking. Yeah, that's in general the thing that we are going to show on this demo.
Okay, let's go to the demonstration. I already have some terminals here to show it. We already defined a little architecture to show you the experiment. I'm just going to run it.
Yeah, right now in this YAML, we have the deployments, the client, the Apache, and everything. So we are going to start applying this YAML. Just let's wait for that.
I think it's still running.
Yeah, right now. Yeah, the first time takes a little bit just to respond the API of Kubernetes. Yeah, so right now we have created the deployments, the service, the config, and everything that we have. This experiment is based on some examples of Linkerd webpage and some examples of the Chaos Mesh website. Right now we are going to start the dashboard of Linkerd. Well, in the namespace of chaos testing, we have this awesome graph that shows how the client is calling Apache. And if we go to the Apache deployment, we can see that it's going to show, well, maybe the traffic in the downside of the page. Well, this graphic, yeah, you can see the traffic on real time and what pages are calling and these things. And this graph is showing the success rate, requests per second, and how the traffic is moving. Maybe we can go to the Grafana dashboard. That is the important thing, just to visualize what is happened. So Linkerd provides you with Grafana dashboard, and you can see the goal metrics here, the success rate, the request rate, request per second, and the latency. And maybe we can move the refreshing to 5 seconds. Yeah. So basically right now, this service is stable and everything is running. But what is going to happen if we inject faulty traffic? Let's do it.
So we can see in the background, that's the healthy state of our architecture. Now, when we start applying some faulty traffic, as Sergio said, this is going to start changing a little bit. Okay, right now the traffic split and the faulty container is being created, and the metrics will start change a little bit.
Yeah, right now you can see that there's a new thing. There's an error injector that shows in red, that shows that it's an invalid traffic. Right now we are going to see the traffic splitting. That right now we set the traffic splitting to 10% to the faulty traffic container and 90% for the Apache. And in the side that you're looking to the service Apache, in the success rate that is in orange color, more or less between you have 10% of faulty traffic or invalid traffic, you are going to take an average of success rate of 90%, and you can check in the service Apache that is in orange color, and of course it's 90%, and the service mesh is calculating these things for you without modifying your container and these kind of things. Yeah, it's really awesome to get this traffic on real time. Right now, let's move to the golden metrics again, just to see. Well, right now we have 69 requests per second, and well, of course, right now is the service is affected by this faulty traffic container. Yeah, that's the cool thing. You can complement or see what is happening with a service mesh to get this kind of more return using the golden metrics. So right now, let's move to the chaos mesh experiments.
Right now, let's see my favorite part, that is crashing the architecture using chaos mesh. The experiments that we're going to apply are the pod kill and pod failure, applying to the Apache server. Okay, right now both experiments are running. I'm going to open the chaos mesh dashboard just to make the contrast between the dashboards and the information that we can see and complement. Okay, right now, as you can see, the request rate has become more stable. This is because besides the faulty traffic that is only at 10%, both chaos experiments are running. We're going to see the pod state. Okay, as you can see, the objective of this experiments. Well, the pod failure is cause random failure into the pods, and the pod kill, of course, terminate these pods completely. As you can see, here are some pods that are running, and then they're crashing, some of them failing, and this is going between 6 seconds for the pod failure and every 3 seconds for the pod kill.
I think that another cool thing is that you can also observe in the part of, well, in the request rate and the latency, that is like a kind of downtime for the service. In the inbound deployments, in the part of the, yeah, in that part, there are another metrics for the service. You can see that periodically, there are like a kind of downtimes that reflects how Chaos Mesh is working in that part. So let's move to the dashboard of Chaos Mesh.
Okay, for example, in Chaos Mesh, as we can see, we have 2 experiments running, the total state, 1 experiment running because the pod failure is constant. This refresh every 3 seconds with every pod kill. We can also here look at the state of the experiments. The only one that is constantly running is the pod failure example because we define it this way. We're going to see. As you can see, the experiment is going to cause some pod failure every 6 seconds, and the duration of this failure is going to have 3 seconds. Comparing with the pod kill, that is going to run or kill a pod every 12 seconds, and the duration is immediate. I mean, this takes a pod and kill him. The linker D is in charge of trying to recover all of this. We can also look here the timeline of the experiment. There are some time between each other every time they're running. And as Sergio said, in the metrics, we can see how it started with more than 1,000 requests per second, and now with the faulty traffic, both experiments running, all the architecture is, well, let's say completely crash. That is one of the good things of chaos engineering. See how the architecture completely crash with every different experiment that we try.
Yeah, maybe we can try to remove the faulty traffic to see how the architecture recover itself.
Okay, let's see.
Well, we can expect that in some minutes the system is going to recover in some way. Maybe we can remove
The chaos mesh experiments.
yeah, the chaos mesh too, just to recover the.
Okay, now the chaos mesh experiments and the traffic fault are stopped or deleted. As you can see back there, the request rate per second is really low. In some seconds, this is going to start increasing again as the beginning, and it's going to get into the stable state of the system.
Well, as we can see, well, I think that this experiment was too much for all the services. Maybe we can try to, well, it can take maybe more minutes, but maybe we can try to remove the client again and redeploy the thing. Is the Apache YAML. Yeah, sometimes, as we were testing in some experiments, sometimes the architecture survive and other ones doesn't survive. So it's like a part of this kind of experiments. You are missing the dash F.
Sorry.
Yeah, so yes, it's like this part of you have a theory to prove with this kind of tools, and you have to see what is happened, like take some statistics and get a general performance on what your service is doing and these kind of things. Where right now is like a kind of downtime because we are going to redeploy the thing. But in some seconds, we are going to get the service deployed again and get all the things in order. Right now, the things are running nice. Yeah, so right now the request per rate is really, really nice. I want to mention that our deployment has some replicas. It's not only one deployment with one container. This is a deployment with several containers to get some kind of redundance and failover thing, just like a kind of small experiment. So yeah, that's in general that the things that we are testing, we can move the parameters, get different results and everything. But the cool thing and the important thing is how Linkerd with their dashboard and how the way is getting golden metrics, how you can complement a service mesh or a tool like this with a chaos engineering tool, and how can complement each other. That's the cool thing about how we combine a service mesh to get these golden metrics and the chaos engineering and chaos mesh to get our experiments and these kind of things, and how Linkerd can show the behavior of the network and the success rates and everything, and how with these tools you can get really important information to modify and to improve your architecture. That's in general the idea and the thing that we are working on this thesis.
Yeah, as Sergio said, also we accomplished with the chaos engineering objective, which we cause a fault in the architecture to see if it can support extremely bad conditions and get recovered or really crashed. Now, as we could see, the architecture crashed completely and it was very difficult for it to recover. Now, the next step will be improve the architecture. Of course, this was a test architecture, something simple, not like, let's say, a Death Star architecture, right? Now let's turn back to the presentation. Okay, some lessons that we have learned at the moment. First, how to implement step-by-step chaos experiments. Implement chaos experiments to improve the system. It's not as difficult as it sounds, as we saw in the demonstration. Understand how an student thesis can help open source project and the industry to grow up and solve some real life problems. Now, what's coming next? Well, some objective of doing this thesis and having this opportunity being here today, talking with the experts of Chaos Mesh, was also show the students in my university that there are a lot of opportunities to do research outside our country, to contribute with the communities, and that more students can get involved into all of this, right?
Yeah, and I think that I want to add something. I think that, as Jossie mentioned, to contribute and to get involved with students in the CNCF ecosystem, I think that that's really awesome. The way that we came here to the Chaos Mesh community meeting is like because I proposed to Jossie to work and send a proposal to the KubeCon and the Service Mesh Con event and show what he's doing with his thesis and these things. We choose, or they choose our proposal. It's like a kind of motivation for a student to push him to work in his thesis and do some research and see what happens. And yeah, we are getting unexpected things like talking with you guys. That is really, really awesome. Yeah, so that's the other thing that is coming next, the Service Mesh Con.
And of course, you can follow us. In my case, my Twitter.
Yeah, that's my Twitter too. You can follow us.
And in this link, we're going uh, to leave the slides if you can or want to check them later. And of course, again, thanks for the opportunity, not just for talking with you guys, also for the opportunity to show this in my country, uh, for all the students here to see that we also have the opportunity to do the research, contribute with the community, CNCF, Chaos Mesh. That is, I think it's really cool tool to unleash chaos experiments.
Yeah, so yeah, for me, thank you very much to all people for this space to share about the things we are doing. We are so far from the other continent and that thing. So yeah, thank you very much for that. I don't know if you have questions or something. We are open to that. Thanks, Mila.
Yeah, thanks, guys. So if anyone has any questions, you're welcome to ask or ask later in the Q&A session. Any questions?
Hello,
Hi,
can you
Kevin.
hear? Can you hear me?
Yeah.
Yeah. Hi, Sergio. Hi, Jossie. I am Calvin. I'm also one of the maintainers of Chaos Mesh. Because I'm not on the tech side, so I will not ask questions regarding the sharing. I just want to say thank you for this talk. I really, I mean, learning actually all these concepts and how you use Chaos Mesh and linked. And just as you said, because you're across the continent, so it's really amazing that Chaos Mesh projects like Chaos Mesh like bring us together and connect us. Yeah,
Nice. Thank you.
yeah.
Thank you.
Just want to say thank you. Yeah, and also there, yeah. But there's one more thing I would like to mention here. I know Jossie is working on your thesis on chaos engineering. But you must be really busy. But there's something we are working on. Actually, we are working together with Litmus Chaos, and we are writing something academic. It's called chaos engineering and for cloud native white paper. It's a white paper, and it's we are writing this under the proposal of CNCF. We're just starting laying out the outline, and maybe if you are available, we can ask. Sometimes we can ask for your review, if that's possible. Yeah.
Yeah, for sure. We are open.
Yeah, of course.
Yeah.
As I just say, I've been really busy. There have been some non-sleep nights, but I will really like to help you as I can. I'm available on my Twitter, on my mail. I think you already have it, and of course you can ask me for any retrospective. I will be pleased to give it to you guys.
Great, thank you.
Yeah, for
thank
sure.
you. We can talk more later.
Yeah.
Yes, of course.
Thank you.
I think that both we already are in the CNCF Slack.
We can. There is a channel and the CNCF for this white paper writing. I can invite you both to the channel.
Yeah, for sure.
Sure. Thank you.
Thank you, Calvin.
So if,
okay, Mila.
Yeah, if there's no more questions for now, I will ask Chungwen to update y'all with the technical side of Chaos Mesh. Chungwen?
Well, I think your new question in chat input.
Yeah, I will look into that. The recording will be uploaded later on the Chaos Mesh YouTube channel, so no worries. We will update the Twitter and the meeting notes as well to put all the slides and materials so that you can access it later. And I will put the meeting notes link here. Hold on, let me just find it. But in the meantime, Chungwen, you can start.
Okay. I will share my screen. Can you see my screen?
Yep.
Okay. Hi, I'm Changwen. I'm maintainer of the Chaos Mesh. And here I will show some technical updates on Chaos Mesh in this month. Okay, the first one about the new features. The first new feature is about Chaos workflow. If you join our last community meeting, you maybe know then we will add a Chaos workflow in our Chaos Mesh, and also we have a demo about it in last community meeting. And here you can find it and find the video on our YouTube channel. And in this month, we have merged this feature in our master branch, and you can use it in latest version. And present, you can define the chaos workflow in YAML files, and also you can manage a group of the chaos, such as if you want to some chaos action in orders, you can use it. Also you can use some chaos action, and same time you also can use our chaos workflow. And also in next month, we will start to define the chaos workflow in our chaos dashboard. Okay. The next is about GCP chaos. And in this month, we we add GCP chaos to simulate GCP node failures or disk failures. And another's and also we remove the allowed namespace and the ignored namespace configuration from Helm-child. And also, if you want to enable or disable the all chaos action on the specific namespace, you can use a specific notation to do it. Okay, the next is about some features we are developing, and here is about our we will use a unified selector and implement a new controller. And this is our design document. And here is discussions. If you are interested about the feature, you can join us. And this feature will be abstract a selector from controllers and trace the roaming status of the every selected target. And also we will add some new controllers such as a during controller, which can use to measure the logic of the during time of the chaos action. And here these features we will remove the schedule from the chaos object and will be add a new scheduler object. This is a new CRD object. This object will be include two paths, and one path is schedulers, and another path is the chaos object. If you create this object, there will be create the chaos object automatically. Okay. Next is about chaos-D. Chaos-D is a single component and to inject failures to physical node or VM node. And in this month, we spot disk attacks. You can use chaos-D to simulate some disk failures or some disk fail or to simulate the write or read players on your specific disk. And also we reflect the server and the command components of the chaos-D. This reflect is very good and make our logics more clear and is more easier to add the new chaos. And also in this month we end the GOM attacks on chaos-D. But this PR hadn't been merged into master. When this PR was merged into master, you can use the GOM attack to simulate some failures on GOM application, such as Kafka and so on. Okay. Okay. The next is about release. In this month, we have 2 patch released, and here is 1.1.4 and 1.1.3. And this patch release will maybe fix some bugs on your environment. You can, if you have some bugs about chaos match, then you can use this release. Maybe this can fix if you okay. Next is about version 1.2.0. In this version, we maybe will release in tomorrow, and in this version we will support GOM chaos and AWS chaos, and also we will support CRI IO container runtime. Yes. Okay, if you are interested about this release, you can wait our new release and download it and upgrade your chaos match. Okay, and here is our search about chaos match compatibles Kubernetes version requirement. Here is our issue if you are interested. About this, I have some comment. At present, we are using the version 1 alpha's CRD version, and this will be dropped about the new Kubernetes. And we plan to upgrade our CRD version. Maybe we will lead to some older Kubernetes version can't use the chaos match. So we have this research for you. Okay. Okay. Hi.
Yep. Can you like pause and I will start sharing my screen?
Okay.
Thank you. So for the quick community update. So right now, Chaos Mesh has been added to Civo's Kubernetes marketplace. And that basically means you can deploy Chaos Mesh and start creating chaos on your Kubernetes clusters with just a few clicks. And the tutorial and the demo will be coming very, very soon. We're still working on it. And of course, KubeCon EU is starting in, I think, just a few weeks, less than 2 weeks. And we've got a lot of things planned. We have 2 Chaos Mesh office hours planned, which is going to take place May 6th or 7th. And then we have 2 talks, which is the first is by Sergio and Jossie, who are both here today with us, which will happen, I think, May 4th. And then there's also another talk by Siam and Kartik at KubeCon, which is going to happen May 6th. So make sure to check them out. And then there's also the bug bash that we're going to be participating for you to sort of find and kill bugs for Chaos Mesh, but we're still working on that, so more details will be coming next. And before I forget, we will be uploading the slides in the meeting notes, and I've just sent the link to the meeting notes to the chat box, so you can check that out later. And right now it's the Q&A session. Anyone has any questions or like to discuss anything, you're welcome to unmute yourself.
Yeah, sure. So thanks for this update, guys. And I have a couple of questions. So with this 1.2 release, which is about to come, so we are going to get this workflow feature with that, correct?
Hey, Chongwen.
This
Hi.
this 1.2 release, are we going to get this workflow feature that we just talked about? Will that be available for users to use?
Oh, I'm sorry. I didn't understand your question. Can
Yeah,
you
I'm
repeat?
saying this workflow feature that you just talked about, correct? Where you can mention like multiple chaos in a single YAML file, correct?
Multiple, sorry?
The multiple chaos in a single YAML file, that workflow that is
Multiple
already,
chaos in a single YAML file.
yeah, that's that workflow I'm talking about. So will is that already released or that will be part of this? I'm not sure.
Yeah, I think I could answer this question. The workflow feature is the big feature for 2.0, and it just merged into the master. So I'm afraid you could not use workflow at 1.2.0, but you could
Okay.
use the master branch. Yeah, it's the latest branch.
Got it. Got it. Thanks. Thanks. And other
You're welcome.
other question I have quickly regarding this, I'm hearing from some time is like HTTP chaos. If any update, if you guys can share on that as well, that will be awesome. Because that's like very big ask from my team to have that feature as well. And I'm saying that yeah, it is coming, it is coming, and it is coming. But at least some high level, like what will be the flow and when we can we expect that at least in 2.0, or like is it active development going on in this area, and any update on those lines?
Sorry, I could get your point. Do you miss
Yeah.
the HTTP chaos?
Yes, yes, yes. HTTP chaos, correct.
So I'm sorry. What's your question? I'm sorry.
Yeah. So in the question is like when I think I'm even following up with that on select our select channel as well. But I just want to know like is the active work going on that front as well, and when we can expect that roughly? Yeah, like will it be in 2.0, or this will still going to take some time, like design and all is being finalized or not?
Oh, I think I could share some design of the HTTP chaos. The HTTP chaos is also the big feature of 2.0. Is that right, Truman?
Yeah,
The
the HTTP
2.0.
chaos.
Yeah, yeah, yeah,
The
yeah.
HTTP
And we
chaos
will
PR
use.
is has been on our GitHub repo. You can find this PR, and when it's okay, we will merge in our latest version, and we also will release in our version 1 version 2.
Yeah, I think HTTP chaos will available in several weeks.
Okay, that should be fine. I just want to know, like, is it like still is a active work that you guys are doing on those front, or like because there are so many things comes in a priority, correct? So just want to get some clarity on that part. Yeah, thanks. So I think looks like it is in active mode.
Yeah, it is an active. We're actually working on it right now.
Perfect. Thank you. Thanks you. And one more, I just want to say thank you guys. Like I think I am whatever the queries that I put it out on your select channel, I in a day time, I will say even in a less than a day, I always get reply. So thanks a lot to all you guys, because I started like in a quarterback, and I have so many questions. I'm just working on kiosk mesh from my side. I will say nothing else, and driving this effort at my side. And with obviously those queries comes, and I think you guys are helping me out even to really forward. Thanks a lot for all that.
Oh, you're welcome. And we thank you for your being so active on Slack and writing articles on Chaos Mash. We're super thankful for that as well. Thank you.
Thanks.
Sorry, how to pronounce your name? Anurag, is it, or?
That's correct.
Awesome, noted. So any more questions? So if no one else has anything to add, I think we'll wrap this up. Okay, so I think that's it. We've got a great show tonight or this morning for our friends in Guatemala. But see you all next month, and don't forget to follow Chaos Mesh on all forms of social media for the latest updates. And thank you all for coming tonight. Good night.
Good night.
Good night, guys. Bye.
Good night.
Bye
Good
bye.
night.